Hi everyone, my name is Linna Li. I'm a public health physician in Ontario, Canada. I'm speaking about tests of hypothesis today with the aim of doing a broad overview of the t-test and chi-squared test. The t-test and chi-squared test are some of the most common tests of hypothesis. They are foundational tests that many variant tests are based on, and so it's important to have a good grasp of these two tests. There are also many important tests that are quite different from these two tests, such as the Poisson distribution, non-parametric tests, etc., which we will not be covering in this video. The purpose of tests of hypothesis in biostatistics is to translate the questions that you have from words into the language of biostatistics, formulas, variables, and calculations. They answer the question, are the data at hand compatible with the hypothesis? In order to answer this question, we must have a testable hypothesis, that is, a hypothesis that we can translate to fit our biostatistical language, and a predetermined threshold for considering data to be compatible or non-compatible with our hypothesis. In the language of statistics, this is phrased statistical significance. In the remainder of the video, I will be focusing on the t-test and chi-squared test. In general, which test you do of these two depends on the type of dependent variable that you have. As a reminder, the dependent variable is the outcome variable, and the independent variable is the input variable. For example, if we ask the question, what is the relationship between gender and weight? Gender is the input variable, the independent variable. It's the starting variable, the variable that cannot be affected. Weight is the output variable, the dependent variable. It's the resulting variable, the one that can be affected. Another way to think of it is we can ask the question of whether a person's gender somehow affects how much they weigh. We cannot ask the question of whether a person's weight somehow affects their gender.